Okay. So as I was saying, up till now, most of the time you're given a graph, f of x, then told a rule and asked to graph the new graph. In this question, we're given the graph of f of x. We're not told what rule happened, but they give us the final graph. And they give us a bit of a hint in this one that there was a vertical and horizontal compression that happened to this graph. So one of the things that we can do is we have to sort of use the answer and work backwards. And a strategy that we had developed the other day was we had said, okay, if you take a point on the original graph, or a couple points, so I have 3, 9, I have 2, -8, and I have 0, 0. And we know that something's going to happen to these points, and they change, and the one changes to 1.5, 4.5, another one to 1, -4, and 0, 0 stays at 0, 0. And we have to think, what could we put above that black arrow to describe what's happened? So let's look at our x values first. 3 changed to 1.5, 2 changed to 1, 0 changed to 0. Can you see a pattern happening here? What happened to our x values? Our x values got multiplied by a half. Okay? You might be tempted to say when you see 2 to 1, you say, oh, maybe it moved left 1, but then moving left 1 doesn't work for this 3 to go to that 1.5. So we have to come up with a pattern or notice something that happens for all of the x coordinates. And same thing with the y coordinates. 9 went to 4.5, -8 to 4, 0 stayed the same. You might notice that the y value got multiplied by half as well. We need to write an equation in terms of the function f. Now an equation means we need an equal sign, we need something on both sides. So I'm going to put y equals. For my blue graph, how do I show, in terms of the function f, multiplying x by half and multiplying y by half? Well, everything that affects y is outside of the function. Everything that affects x is inside the function. So this y by half, I'll have a half outside. That x by a half, inside I will have not a half, but a 2x. Because remember on Friday, we learned that for horizontal stretches and compressions, you always multiply by the reciprocal. So things that happen inside the function seem to sort of be opposite. Moving left and right was opposite with the plus and the minus. And then for stretches, if you have a 2 inside, you're actually multiplying by the reciprocal, multiplying by 1/2. I'm going to teach you a secondary technique for this, because as we move into the next section, the arrows alone won't be enough to figure out what's happening. So a secondary technique or method to, which I'll title compare is comparing horizontal and vertical changes. And on my graph, I'm going to label this as point A, and this is point B. And the corresponding points, and you'll see this sometimes in textbooks. We're going to label a point A with a little dash, A prime, and a B with a little dash, B prime, to make the connection that A goes to A prime. I'm going to show here, this is A, this was A prime, this was B, this changed to B. So method 2, and method 2 is going to work when we add even more transformations to this. Method 2 says compare your horizontal and vertical changes. So if we look at horizontal, in the original, from A to B, if I labeled my A up here and my B back here, I'm going back 1. If you're going back 1, you're going to write -1 because you're going 1 to the left when you go from A to B. And then I look at my image graph and its horizontal distance from A prime to B prime, and it goes back a half from 1.5 to 1. This tells us when we compare, if I want to go from the red to the blue, I would have to multiply x by a half. When I compare my vertical distances, again on my red graph, when I go from A to B, I'm going to go from 9 down to -8. I'm going down 17, so I would write that as -17. And if I look at A prime to B prime, I go from 4.5 down to -4, which tells us our y values had to be multiplied by a half as well. And we're going to find that we're going to need method 2 and method 1, sort of a combination as we get into more complicated ones. But the questions I'd like you to circle right now are 5, 12, 13, and 14. And then I'd like you to turn to page 192. 192 is a page that's completely blank. And sometimes we're going to add some extra examples just to practice. And sometimes we're going to use those extra pages to do that. So we're going to graph this. Oops, I wrote it a little bit wrong. Sorry. I wanted to have this. Like that. And we're going to walk through the process. If you had a question like this on your test, what you would have to do and how you would go about graphing this. Okay? The textbook likes to give you a graph first and then ask you to do something. But you're going to get some questions that relate back to our colored pages where you have to know the graph first, know points on your original graph, and then do the changes. So first of all, in a question like this, we need to recognize the parent graph is x cubed. And in your head, you should have the shape of x cubed and know 3 key points on that graph. So we have 0, 0, 1, comma 1, -1, comma -1. Then we're going to notice in our equation that we have some numbers, right? We don't just have x cubed. What do we have? We have a 3 out in front. What does that 3 do? That 3 is out in front, so it's going to be vertical. You're multiplying a vertical stretch. You're going to multiply your y values by 3. Inside, we see a negative and a half. The negative will be a horizontal reflection because that negative is getting cubed. The half is getting cubed, so that is going to be a horizontal stretch. We're going to multiply our x values by -2. So on our original graph, we had 1, comma 1, 0, comma 0, and -1, -1. And according to the equation, we've noticed that we have a vertical stretch, horizontal reflection, and horizontal stretch. So above these arrows, we can write what we need to do. I need to multiply all my x values by -2. I need to multiply all my y values by 3. If I do that, I'm going to get new points. And my new points I'll do in purple. I would get -2, comma 3, 0, comma 0, and +2, -3. If I go and label those, -2, comma 3 would be there, 0, 0, and 2, -3. And I need to have the same shape as my original graph going through those points. Now, I mentioned earlier that this course is really particular about details. If I would give that as my answer on my final exam, I would lose a half a mark because I did not label, even though I have, like, it seems obvious, okay? It seems obvious that I've labeled points here and that I drew a graph and have dots. But if your graph doesn't have a scale, if your points aren't labeled on your graph, you're going to lose a mark for clarity. It's an E9 error, they call it, because you haven't provided a scale for your graph. As soon as you label one point like -2, comma 3, then your scale is automatic. So if you didn't label to -3, it would be okay because it's obvious that each of your marks are going by 1 after labeling one point. Always good to label all the points because sometimes the point that you label is an x-intercept or a y-intercept, then you still haven't provided a scale for one of them, either your x-axis or your y-axis. So labeling a couple of points, actually labeling on your graph will be important.